Question number 81 says that position vectors of point A and B are A vector and B vector respectively. Magnitude of A vector is 2, magnitude of B vector is 4. Then the ratio in which the median of triangle OAB passing through the vertex A divides the internal angle bisector of triangle OAB passing through vertex O. We'll have to draw triangle OAB. We have to draw the median of the triangle through A. Then we have to draw the internal angle bisector of OAB passing through O. Okay. So let us have the diagram over here. This is the diagram. OAB is a triangle. AD is the median. If this point has position vector B vector, D point obviously has B vector by 2. This is the internal angle bisector of angle AOB. These two angles are equal. Let this point be P. Now students, we know that the internal angle bisector divides the opposite side into the ratio of sides containing the angle. So this ratio AP is to PB is 2 is to 4 or 1 is to 2. So what are the coordinates of point P? The coordinates will be, this ratio is 1 is to 2, let us say. This will be B vector plus 2A vector by 3. So these are the coordinates of point P. We know them in the form of B vector and A vector. Now the question is very simple. Write down the equation of OP, write down the equation of AD, find out their point of intersection. Let us say this point is X. Okay. Find out their point of intersection, find the ratio OX upon XP. So now let us simplify it. Equation of OP. R vector equals 0 vector, that is the position vector of origin, 0 vector plus lambda times P vector minus A vector. So basically it is lambda times B vector plus 2A vector by 3. Equation of AD. R vector is equal to A vector plus mu times B vector by 2 minus A vector. Solving OP and AD simultaneously, we get the point X. So let us solve them. Lambda times B vector plus 2A vector by 3 is equal to A vector plus mu times B vector by 2 minus A. So we need to compare the coefficients of A and B on both the sides. Coefficient of A vector 2 lambda by 3. From here it is 1 minus mu. And coefficient of B vector lambda by 3 equals mu by 2. From here you can solve lambda and mu. Lambda comes out to be equal to 3 by 4 and mu comes out to be equal to 1 by 2. Okay. So if lambda is 3 by 4, mu is 1 by 2, what are the coordinates of point X? Point X lies on the line OP. So it is lambda times B vector plus 2A vector by 3. That is B vector plus 2A vector by 4. X point has the coordinates. So X point has the coordinates B vector plus 2A vector by 4. From here directly we can conclude that OX upon OP is 3 by 4. That means OX upon XP is 3 by 1. Okay. From the coordinates of these 2 points we can directly conclude this. So that means option number 3 is the correct choice again. Okay. Let us move on to question number 82. Question number 82 says that if the lines AX plus BY plus CZ plus D equals 0 equals 9x minus y minus z plus 10 and x plus y minus z plus 2 equals 0 equals 2x minus 3y plus 2z equals 0 are coplanar, then which of the following is always incorrect? Let us solve the line of intersection of these two planes first of all. What are the DRs? DRs will be perpendicular to both the normal vectors. IJK 1 1 minus 1 2 minus 3 2. So that will be 2 minus 3 minus I cap, then 2 plus 2 minus 4j cap, then minus 3 minus 2 minus 5k cap. So DRs can be taken as 1 4 5. Let us solve any common point on the planes. Let us put y equals 0. So by putting y equals 0, I will get x is minus 1 and z is 1. So now let us write the equation of the line of intersection of these two planes. The line of intersection is x plus 1 upon 1 equals y minus 0 upon 4 equals z minus 1 upon 5 equals lambda. Let us say the general point is P. Lambda minus 1, 4 lambda and 5 lambda plus 1. Let us satisfy it in the equation 9x minus y minus z plus 10 equals 0. So 9 into lambda minus 1 minus 4 lambda minus 5 lambda minus 1 plus 10 equals 0. So that means 0 equal to 0. This point P lies in the plane 2. So this is plane 2, let us say. Now students, if these two lines are to be coplanar, that means plane 1 and plane 2. This is plane 1, which is the variable plane. This is plane 3, this is plane 4. So plane 1 and plane 2 must have a line of intersection. That is the only condition left now. That means P1 must not be parallel to P2. So for this condition to satisfy, ax plus by plus z plus d should not be parallel to 9x minus y minus z plus 10 equals 0. That means a is to b is to c must not be equal to 9 minus 1 minus 1 or minus 9 1 1. That is option number 3. Okay. The question is asking which of the following statement is incorrect. There is only one possibility in which will not obtain any line of intersection of plane 1 and plane 2. So that is the answer. Okay. Let us move forward to 83. Question number 83 says that which of the following is a pair of perpendicular lines. Now students, two lines are perpendicular if the dot product of their parallel vectors is 0. You just have to take the dot product of the denominators. Checking through each of the options, you just have to give the answer. So let us take option number A. The dot product b1 dot b2 will be minus 9 minus 2 plus 4 non-zero. So they are not perpendicular. Option number B, definitely it is positive. You can see that all the factors are positive. Positive, so non-zero. C, again non-zero because it is positive, all the three factors. Obviously, last option will be our answer. Let us confirm it for a while. B1 dot B2. 28 minus 9 minus 19. So yes, that is equal to 0. If dot product of two vectors is 0, those two vectors are perpendicular. Correspondingly, two lines which are parallel to these two vectors, they will be perpendicular amongst themselves. So option number 4 is correct. Very simple question. Just by option checking, you can gain 4 marks. Let us move on to question number 84. Question number 84 says that distance of the plane x plus y plus z equals 0 from the point 2 minus 3, 5 when measured parallel to the line x minus 3 upon 1 equals y plus 4 upon minus 1 equals z upon 1. This is a standard problem which has been seen everywhere. It's a very standard problem. So let us start it by writing the equation of line passing through this point and parallel to this line. X minus 2 upon 1 equals y plus 3 upon minus 1 equals z minus 5 upon 1 equals lambda. Now obtain the general point on this particular line and solve it with the plane. That will be the point of intersection. So P point is lambda plus 2 minus 3 minus lambda and lambda plus 5. So solving it with the given plane x plus y plus z equals 0, what we will get? We will get lambda plus 4 equals 0. So lambda is minus 4. What are the coordinates of point P? Point P will have the coordinates as minus 2, 1, 1. So I need the distance of, let this point be A. I need the distance AP. So what will be AP? Under root of 4 square plus minus 4 whole square plus 4 square equals root 48, and that is 4 root 3. Simple one. Okay. Very simple question. Option number 3 correct again. Let us move on to question number 85. Talking about question number 85, it says that two coins are tossed and two dice are rolled. Probability that both coins have the same outcome and the sum of outcomes on both dice is greater than 7 is. Now students, let us say this particular event is event A. As the tossing of a coin and rolling of a die are obviously independent events, we'll just multiply the probability of both the events. Both the coins have same outcome. That is 1 by 2, because in total there are 4 possible outcomes and head and tail are the favorable outcomes. Sum of outcomes on both die is greater than 7. So either sum is 8, probability is 5 by 36, then 4 by 36 for sum 9, 3 by 36 for sum 10, 2 by 36 for sum 11 and 1 by 36 for sum 12. This is the final answer. Very easy problem. 1 by 2 into 15 by 36, and that is equal to 5 upon 24. Okay, cancelling on the factor of 3. Option number 3 satisfies. Fine. Let us move on to question number 86.